Hi guys, so we're still working through these segments that form in triangles, which these two kind of form a triangle. They're not really in a triangle, but they form a triangle when we get done talking about it. So, perpendicular bisector and angle bisector theorem. Let's talk about what these things mean. So we've already talked about what the word perpendicular bisector, we've already talked about what that word means. So, what does perpendicular bisector mean? Well, you are correct. A perpendicular bisector is a segment that intersects another segment at the midpoint, because bisector means to slice in half. It's violent. So we'll hit at the midpoint. And then perpendicular means to also form 90-degree angles. So a perpendicular bisector will hit a segment at the midpoint and form 90-degree angles, which is pretty cool in my opinion. And an angle bisector, which again, we've talked about what this means. What does the word angle bisector mean? Holyata, you guys always know the answer. So angle bisector, what that is, this is when some sort of object hits an angle. Bisector means to slice in half. So it hits the angle right in the middle, which will make two congruent angles. So there are some nifty properties that will come about if points are lying on a perpendicular bisector or if they're lying on an angle bisector. So let's talk about those individually. All right, so before we get started on that, we need to talk about what the word equidistant means. So the word equidistant, what does that word kind of sound like? Equidistant. Oh man, you guys always know. So the word equidistant kind of sounds like the word equal distance, right? So basically, you guys, the word equidistant means when a point is the same distance from two or more objects. So it's when something is the same distance to something else, which is pretty cool. So that is the word equidistant. Try saying that 5 times fast. Pretty weird, right? All right, let's keep going. So we have to know that to know what the perpendicular bisector theorem is. So the perpendicular bisector theorem states that if a point is located on a perpendicular bisector, then it is equidistant from the endpoints of that segment. So I have a visual to kind of help you kind of understand what this means, because that's a lot to kind of put together. So if you guys see here, this ray, it's technically a ray, this ray right here, ray x to the y, okay, when it hits segment AB, first of all, it forms 90-degree angles, so it's perpendicular. Secondly, it makes two congruent segments, which means it's hitting the midpoint, which is y. So that means that point x is sitting on a perpendicular bisector. Okay, so xy and AB are perpendicular, that's what that means, which means, and it's also bisecting it, which means y to the A is congruent to y to the B. So, if you have a point that is sitting on a perpendicular bisector, which x is sitting on this perpendicular bisector, what that means is that it's equidistant or the same distance to each endpoint of the segment that is perpendicular to and that it's bisecting. Okay, so since point x is on a perpendicular bisector, it is equidistant to each endpoint of this segment. Okay, that is true with any point located on a perpendicular bisector. So like if point x is right here, if I were to draw two little segments to points A and B, they would also be equidistant. If I had point x here and I drew in two segments to points A and B, they would be the same distance. So any point on this line, if you connect them to points A and B, will be the same. Okay, so pretty cool. So in this case, the length of XA will be congruent or equal to the length of XB. Sorry, guys. Okay, the converse of this theorem is also true, which all the word converse means is that you reverse the previous statement. So before, we said if a point was on a perpendicular bisector, it's equidistant. Now we're saying if a point is equidistant from the endpoints of a segment, then it has to be on the perpendicular bisector. So we're reversing the perpendicular bisector theorem, which is pretty cool. Okay, so if I have some point, which in this case it's x, if I have some point x on this suspicious ray, it looks quite suspicious, and it is the same distance to 2 points that are the endpoints of a segment, what that means is that point has to be sitting on a perpendicular bisector. Okay, so this has to be hitting at 90 degrees and making two congruent segments. So pretty cool, right? Alright, so if you want to make a little subcategory in your notebook, the next two examples pertain to the perpendicular bisector theorem. So you can either continue on where we left off and call this like example 4 and 5, or I just called it perpendicular bisector theorem and called them example 1 and 2. So go ahead, pause the video, and go ahead and watch example 1 and 2. It'll be a fun time for perpendicular bisector theorems. Alright, wasn't solving for perpendicular bisector theorem stuff exciting? It totally was, I agree. But we haven't had enough fun yet, right? We need to talk about the angle bisector theorem now, which is almost as fun as the perpendicular bisector. It's actually just as fun. I just lied. Sorry, guys. But anyways, the angle bisector theorem states that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So if we have this suspicious point, which I don't have it on here, but it should be a C right here. I don't know what happened. But anyway, so if there is a point that is on an angle bisector, which you can't see it, but down here is a P, so PC. But anyways, if you have a point that is on an angle bisector, which I know that this ray is an angle bisector because it cuts the big angle in half. These two little angles right here are congruent. ACP is congruent to CPB, which that's just to say C. Okay, so if a point is located on an angle bisector, guess what, you guys? It will be equidistant to each side of an angle, which is pretty cool. So if it's on that angle bisector, that means these two lengths are equal, or the segments are congruent. So pretty cool, right? But guess what, you guys? The converse is also true, which remember the converse means we're going to reverse what we just did. So if a point in the interior of an angle is equidistant from the sides of an angle, then it must be located on the angle bisector. Sorry, I almost said perpendicular bisector. Jeez, Miss Long. Okay, so again, if we have a point, the sneaky point right here, that is the same distance to each side of the angle, that means then that it has to be on an angle bisector. So pretty cool, right? All right, ignore that. All right, so now we're going to be tackling example 1 and 2 for the angle bisector theorem examples. Again, you could just pick up where we left off, so that would be example 6 and 7. I just called it angle bisector theorem and called it example 1 and 2. So this is the end of the video. I hope you've enjoyed perpendicular and angle bisector. So go ahead and watch the video now for angle bisector theorem. It'll be a fun time, you guys.